for me to find W, since I've been given hypotenuse, I can do it this way. And I've established one point, but I still want you to follow through with what I'm doing. Now, such that the effect of this force, by the time it's resolved to this place, will be like this. Can you imagine? Think about it. This is the actual force. When it is resolved here, it will pull it like this, right? Good. Now, it will counterbalance this. When you resolve it here, it will be like this. It will counterbalance this. That's actually. So now the question is, where is the angle? This is the angle, theta. So since this is the two lines I want to consider, this angle is the same thing as what you have here. You remember in mathematics, alternate angle, and what corresponding angle. So that means that this angle is the same thing as this angle. Okay. Now, from my explanation, previous explanation, if this is the angle, this side will be the adjacent or opposite. Adjacent, good. Now, this side will be the adjacent or opposite, which is the same thing as here. Good, opposite. So if this is adjacent, I'll use cos. Cos theta. Here it will be what? 10 sine theta. The question says calculate W and theta. Now, if I want to calculate W, I can go with this one and this one. Summation F. Remember, third law. Newton's third law says to every force there is an equal and opposite. To every reaction there is an equal. To every action there is an equal and opposite reaction. Now, meaning that the effect of 5n is balanced up, since this body is in equilibrium, by 10 sine theta. And to say it at equilibrium means that summation F equals to 0. That means that 5 equals to 10 sine theta. Yes, because by the time you bring the negative to this side, it becomes positive. Is that okay? Good. So divide by 10, pam, 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 pam. That means that theta equals to sine inverse 0.530. Then the next, I can go ahead and solve this W using the same concept. Let's put the positive at the right side, following the normal quadrant. Bring it to this side. Then cos 30. 8.66 Newton. All right, let's go to the next. Now, a particle P which is in equilibrium under the action of three forces F1, F2, and F3 as shown above. Which of the following equations are correct? This is the defining part of, you see, when there is a saying, I don't know how universal it is. It says that when the going get tough, I tell you, the tough gets going. You define the tough people by the time the situation is becoming tough and becoming tough and becoming more tough, becoming more tough. Now, we are coming to questions like this. This is where I will now know the people that are actually tough as I am. Now, a question like this is F3, this is F1, this is F2. You can remove this as on their own like this, where you have F1. Then this part, then another part here. I only did this to help aid your understanding. So this has given us a form of right angle triangle. Has also given us another form of right angle triangle. It is now the cumulative effect of, by the time you resolve F1 to this place, you resolve F2 to this place, there will now be a counterbalance for F3, and that is, it is now the effect of this one, this force X, permit me to use X for it, that will bring this into equilibrium. It is the effect of this that brings these two into equilibrium, isn't it? Good. Which in the real sense, it is this one that balances this one balance this. Do you understand what I'm saying? So in the case of this, I will have to resolve both this part, this part, this part, this part, which is simple. First is define where you have your angle, sine or cos. Is it this place? Now this is the angle. This place, is it the adjacent or the opposite? This one, you can see the imaginary line, which is the same thing as this, is the opposite. This is the adjacent. Adjacent, opposite. Adjacent, opposite. Adjacent. Adjacent, I use car. F1 cos theta 1. Adjacent is the same thing, opposite. Adjacent, opposite, opposite. Adjacent, opposite, opposite. That means F2 cos theta 2. If this place is cos, then of course this place will be F2 sine theta 2. F1 sine theta 1. That tells me something, that the effect of this can balance up this. That is, resolving this here is responsible for the one balancing up resolving this here. So that means that I can equate this to this. Remember, like we said, summation F equals to, take the positive one, taking this direction to be positive, F1 sine theta 1 minus, because when you are considering vector quantity, change in direction will indicate a negative sign. That's F minus F2 sine theta 2 equals to 0. Now, this is off. I'll bring it to the other side. F1 sine theta 1 equals to F2 sine theta 2. That means this is correct. The next is this one. Now, since I already said summation F, all the forces, this one, F1 sine theta 1, has balanced of F2 sine theta 2. Now, it simply means I have two forces left. F1 cos theta 1, sorry, not theta, alpha 1, then F2 cos alpha 2. That means that summation F, where should I take as positive? Let's take F3 as positive. Summation F equals to F3 minus Y. The direction is opposite. In the real sense, this imaginary force here is actually the resultant effect of these two forces, which is F1 cos theta 1 plus, or still the same direction, negative, still negative, minus F2 cos theta 2. That shows that this is also correct. So this is wrong. This is wrong. Now, this is the defining aspect of physics. Now, let's go. It's simple. Let's go on. A body X, this is the body of weight W, is maintained in equilibrium under the action of two forces. 5, that's force 1. Then force 2. And the third force, F. 2 horizontal force. Third force, F. Inclined adaptive to the vertical. That means that where is the position of W? That tells me the position of W will be down. This is the position of W. This is the position of W. So it simply means I have something like this. The question is calculate W. I already told you W is vertically downward. Simply means for you to get anything equilibrium, it means that for you to get vertically downward, for you to get W, it simply means that there must be a countering force which should be opposite to W, such that the effect of this vertically upward force cancels out the effect of the vertically downward W. Where that force is from is this F. If you resolve your F, now if I bring that F out, that means I have two forces having effect here. One is 4, which is vertically horizontal. The other is the effect of F, which I am here to get. Now, first is to determine, will it use sine or cos? Now, this is vertical. This is the angle. So this place will be adjacent of this angle. This place will be adjacent of this angle. Why this other side? Or yeah, they are the same thing because they are parallel, will be opposite. That means if this is RA and this is hypotenuse, that means I can use AH, cos. That is, this side is F cos 30. This side is F sin 30. I can't find W until I know F, because okay, this is what I'm saying. Now, since it was W that we were looking for, summation F, considering the vertical forces, taking the upward one as the positive. So it simply means that F cos 30 minus W is in equilibrium, hence is equals to 0. That means F cos 30 equals to what? W. But I don't even know F. So how do I get F? Let's consider the horizontal, all the forces on the plane. Now, that summation F equals to, that's 5 minus 4 minus F sine theta equals to 0. That means that 1 equals to F sine theta equals to 1 divided by 0.5 equals to 2. So if F is 2, that means that W in the real sense equals to 2 cos 30 equals to 1.7 Newton, 1.73 Newton. You are through with this question.